Fuel is drawn from the vehicle tank through an OEM-supplied 300-micron pre-filter by the electric fuel transfer pump. Fuel enters the fitting at the bottom of the ECM cooler located on the left side of the cylinder block. This allows the inlet fuel to absorb the heat generated by the control system electronics to help increase their life. From the top fitting of the ECM cooler, fuel then flows through the electric fuel transfer pump. From the fuel transfer pump, the fuel continues onto the fuel filter head and the optional fuel heater. From the fuel filter head, fuel flows through the engine-mounted fuel filter, which has a 7-micron absolute rating. The filter also contains the water separator. From the filter head, the fuel enters a port in the high-pressure pump housing and is then routed internally to the gear pump. The fuel is pressurized to 6 to 9 bar in the gear pump. Fuel then flows through an internal drilling to the high-pressure fuel pump. The fuel supplied from the gear pump first flows to the fuel return overflow valve. An orifaced flow path in the fuel return overflow valve provides a constant supply of fuel flow. This constant flow is used to lubricate the high-pressure pumping assembly components. As fuel flow increases, the plunger moves up and a passage in the plunger aligns with the port to supply increased flow to lubricate the pump. As fuel flow continues to increase, the plunger moves further upward and uncovers the lower side exit port. This port dumps all the extra fuel that is not used or needed for lubrication back to the gear pump inlet. Fuel delivery to the fuel pumping chambers in the fuel pump is controlled by the ECM through an electronic fuel control actuator in the pump. The fuel temperature is calculated by the EFC coil resistance. As the pump rotates, the eccentric lobed rotor causes the ring to move the plungers up and down in their bores. As each plunger retracts, this allows the check valve to open and allow fuel to enter the pumping chamber. Continued rotation causes the plunger to reverse direction and pressurize the fuel in the pumping chamber. This high-pressure fuel flows out of the pumping chamber through a check valve and combines with the flow from the other chambers. This high-pressure fuel then flows out of the high-pressure fuel pump outlet to the fuel rail. This pumping assembly pressurizes the fuel to injection pressures of between 300 and 1600 bar, depending on current engine operating conditions. The fuel rail is protected from any malfunction causing overpressurization by a pressure relief valve. At 250 bar above the maximum system pressure, the fuel is dumped to the drain by the pressure relief valve. For example, at 1850 bar, a 1600 bar system begins to dump excess fuel to the drain. Pressure is monitored at the ECM by a sensor mounted in the fuel rail. Individual lines supply fuel from the fuel rail to the high-pressure connectors in the cylinder head. Fuel flow continues to the injectors. Fuel flows through the supply inlet passage to fill the injector nozzle and the control chamber above the injector plunger. Injection begins when the ECM energizes the coil and allows the valve ball to lift off of its seat. The reduced pressure above the control plunger allows the needle to lift off of its seat and high-pressure fuel to flow into the cylinder through the nozzle. Since the drain passage is slightly larger than the supply passage, the fuel pressure above the control plunger does not build as long as the valve ball is off its seat. To end injection, the ECM de-energizes the coil, which seats the valve ball. The pressure above the control plunger and the force of the spring causes the needle to seat in the nozzle and end injection. Fuel flowing out the fuel return from the injector flows back to the fuel drain block. The drain line check valve is installed in the fitting in the cylinder head. This check valve maintains 1.3 to 2 bar backflow fuel pressure on the injectors.